Today we're doing our last lesson of Unit 4, Lesson 4-6, which is solving systems of linear inequalities. The assignment that you just turned in today was graphing inequalities. So it was basically a pre-lesson to get you ready for this. If you already know how to graph and shade for inequalities, this lesson should go fairly smoothly. Remember that when you're solving for a system, you're trying to find possible solutions to that system. Does anyone know when I say what is a solution to a system, what I'm actually asking for? It's an ordered pair that will make that inequality true. So when we go through this, we will choose quadrants where we can find solutions. When you think of a quadrant, you have 4, right? Just like all of these. When we label our quadrant, we label it as quadrant 1, quadrant 2, quadrant 3, or quadrant 4. So when I ask you in which quadrant can you find a solution to these two inequalities, you should be able to tell me the name of the quadrant by saying 1, 2, 3, or 4. Or in most cases, it'll be multiple quadrants that you will find solutions in, okay? So just as a refresher, when you graph an inequality, what do you have to do first? And I want you to look at this one right here under example 1. What do you have to do with this inequality before you can even graph it? Are you gonna answer this? I have a question. Okay, hold on. Anyone know? AJ? Yeah, put it into slope-intercept form. At this point, we should be able to simply put this into slope-intercept form without doing a whole lot of work or thought, but you're basically subtracting 2x from both sides, and then this is what you get. Yes, Andy?
So if one of the solutions falls on the axis, would you just say that it's on the axis and not one of the quadrants? Like if it's like 0, 7 or whatever, you would just say that the solution's on the
origin. Axis. The origin, yeah, you could say the origin if you wanted to. Okay, so remember that when we graph inequalities or equations, we start with the y-intercept and then we plot that, and then we graph our slope. So one thing that you may need, and it's completely up to you, would be colored pencils and a ruler. So if you need that, you can get those out right now. Okay, so I forgot to make this negative, so I'm going to make that a negative. Okay. So I'm going to graph this first equation or inequality. Okay, and I'm going to plot my y-intercept at -3. Okay, and then my slope is 2, so that means I'm going to rise 2, run 1. And I go up the whole graph. Okay. Now, don't forget that we have to determine whether we have a solid or a dashed line. So in this case, what does this inequality tell us we're going to draw? Dotted line or dashed line. That's right.
Oh, yeah, whenever they have the line below them, it's solid.
Some people just leave them as dots, and you could do that too. You don't have to write a dashed line. Okay. Now I need to shade this inequality. Am I going to shade above the line or below the line based on my inequality symbol? Below, because y is less than, I shade below. Less than, you go lower than the line. LL, less than, lower, okay? So I'm going to shade below the line. And again, you don't have to shade, you could just draw those lines, but it's harder to tell where they intersect when you do that. So if you want to try it and see if you can figure it out, that's good. That's fine. Okay, so that's my first inequality. And now I want to graph my second inequality, which is this one right here. And you should all be able to do that. Where am I going to plot my first point? 2 on the y-axis. Good. And then my slope is -2. So don't forget to go in the negative direction when you graph this. So I'll go up 2 into the left one. Am I going to have a solid or a dotted line?
Dotted.
Yeah. Okay. So my line looks like that. And now I have to shade. There's a lot of the graphing part isn't hard. It's just remembering, do you have a dotted or solid line? And then which direction do you shade? Those are some of the new concepts that we're learning in this lesson. So can somebody read this to me? Just what Y and then the symbol means. Y is what?
Y is
Greater than. So greater means that we're going to go higher, because the higher we go, the bigger the elevation, or the higher the elevation, or the higher we go, the more. What's another analogy? I forgot what I just keep thinking of elevation, the higher the elevation. So we're going to shade above our line. Now, if I put my arm at an angle, the same angle as my line, and I figure out where is above my arm and below my arm, above my arm's this way. So I lay it down and I'm going to shade above. So I'm going to go in that direction. So that's how I'm going to shade that one.
Oh, that's smart. You don't get them all over your page.
Oh yeah. And I could go quickly. And red and blue make purple. So it's the section that looks closest to purple. It really doesn't look purple, but that's okay. So that's how you graph them. Now, part of understanding this entire concept of systems of inequalities is understand, why are we doing this? We want to figure out, is this section where they overlap a solution? That means that if I were to choose any ordered pair within the overlapped shading, and I were to plug those ordered pairs into each of the inequalities, both inequalities would be true. So we're just going to do this one time. I'm going to choose an inequality, and we're going to plug them into each inequality to see if they're true. Okay, so I am going to choose 5, 2 right there. Okay, so I'm going to choose 5, 2. And below the graph, I am going to take each of the inequalities. Y is less than 2x minus 3. And I'm going to plug my ordered pair into the inequality to see if it's true. So 5 represents my x and 2 represents my y. So I have 2 is less than 2 times 5 minus 3. Okay, are there any questions about what I'm doing here? Okay, now I'm just going to finish solving. 2 is less than 10 minus 3. 2 is less than 7. Is this correct? Yes. So I know that this ordered pair within the shaded region is a solution to the first inequality, but that doesn't mean that it's a solution to the system until I check it with the other inequality to make sure it's also true for that one. In order for it to be true, it has to be true for both inequalities. So I'm going to take the other inequality, 2x plus y is greater than 2, and I'm going to plug in my x and my y. 2 times 5 plus 2 is greater than, and we can already see that that's going to be the case. 12 is greater than 2. Is 12 greater than 2?
Yes.
Yes. So then that ordered pair is a solution. And it is a solution because it rings true for both inequalities. Now, what if I chose an ordered pair here, 1, -6? 1, -6 will be a solution for my blue equation or my blue inequality, what I graphed in blue, but it will not be a solution for my red inequality because it's only in the blue shaded region. The same for the red. If I chose 1, 6 or 1, we're 6 here, it will be a solution to the red inequality, but it will not be a solution to the blue inequality. So if I were to choose either one of these points, it would not be a solution to the system because it's not a solution to both. Does that make sense? Okay. If I were to choose something way out here, it's not going to be a solution to either one. So it's not going to be a solution to the system. So that's how systems of inequalities work and how you determine what the solution is. Now, I could choose any ordered pair within this region, and it's going to be a solution to the inequalities. Inequalities have multiple solutions, okay? So in equations, we wrote what the solution was. We wrote what the ordered pair was, but we're not gonna write what the ordered pair is for the system of inequalities because there's so many. We would be writing forever. So with systems of inequalities, all we're doing is we're graphing, okay, to find the solution. All right. Okay. Let's go ahead and move on to example 2. Both of these are already in slope intercept. So I'm going to graph each one of these. I'm going to shade, and then wherever it overlaps is my solution. Okay, so go ahead and let's graph the first one here. Now, y is greater than 1/4 x plus or minus 0. So where's our y-intercept?
The origin.
The origin. Mm-hmm. And then how are we going to graph 1/4?
Rise 1, run 4.
Yep, rise 1, run 4. And dashed or dotted line?
No.
I mean, dashed or solid line, dotted or solid?
Dash.
Yeah, either one. Above or below the line? Above, because y is greater than. So we go above, higher than the line. Now I'm going to graph my second one. Where do I plot my y-intercept? 4. All right, my run is what? -1. So make sure you go in the negative direction.
And the positive direction also.
Can't do both at the same time. Yeah.
No, negative.
Why is it going that way? Why can't it go like this way instead of like this way instead of that way?
Because it's a negative.
That doesn't make any sense.
Yes, it does. It makes perfect sense. Down
Okay, let's
to
pause
the
for a moment.
right.
Okay, are we going to have a solid or a dotted line? Solid. Shading above or below? Nope, you were right. Below. Okay, now, if I wanted at least one solution for this system of inequalities. In which quadrants can I find a solution to the system?
Where do they
Quadrant 2 and a little bit of quadrant 3.
And a little bit of quadrant 3. So 2, 3, and one more. 1. So we have here would be 1. All of this is in quadrant 2, and this down here is in quadrant 3. So somebody give me an ordered pair that would be a solution to both inequalities.
3, negative 4.
Not 3, negative 4. Negative 3.
Negative 3, 4.
Negative 3, 4. Yeah, up here. Negative 3. And up here to 4 would be a solution. Anywhere within that region. Okay. Any questions?
Nope.
All right. So I want you guys to go ahead and get started on example 3. And you're going to notice with example 3 that the second inequality is a little bit different, but it's nothing new. You've done this before. You just may have forgotten. So let's go ahead and graph the first inequality. Okay, and I want you guys to graph it first and then check it. Okay. So the first equation you should have graphed, and it should look like this. Now the second, anybody have any questions on that? Okay, the second equation is y is greater than 5. What do you notice that we don't have in that inequality?
Yeah, we don't have an x.
We don't have an x, so we don't have a slope. So,
Or we could,
so what we're gonna do is we're going to plot a point at 5 on the y-axis. And remember, we're gonna draw our line through the y-axis, and this is going to be another dashed line. So,
oh no, it's a
horizontal.
The other one. Vertical is a horizontal.
Oh, yeah.
Okay, then since it's greater, we will shade above.
If once it actually intersects the point.
Oh, yeah, and you have to get a medical status.
No, you came up with it. I probably talked with this recently for a while, just around that.
So, which quadrant will you find a solution to these inequalities? Yep, only the first, only quadrant 1. There's no other quadrants, which is not typical. Okay, let's go. I want you all to try example 4 by yourself. Okay, and I will come around and check if you need help. So everybody work on example 4. Just rise 1, run 3 on both of them. Let's see if your inequality looks like mine.
Oh, let's go.
Okay, so if you recall back to systems of equations, when you have parallel lines, what's your solution?
No solution.
No solution. So for inequalities, it's the same. If their shading does not overlap, there is no solution to the system.
Yeah.
So even though there are solutions to the blue equation, and I do have solutions to the red equation, since I don't have any that they share, then there's no solution. Okay, so that's how that works.
They use like all my work.
All right, so we have practiced graphing inequalities. We are going to practice writing systems of inequalities. Now, we've already done this on our last lesson. We did this. So this isn't new. It's just more practice. And I'm going to go through example 5 with you, and you're going to do example 6 on your own. I'll go through example 7 with you. You'll do example 8 on your own. And I'm going to show you how I do it. Now, just because I do it this way doesn't mean that you need to do it this way. But it kind of makes sense to me to write out my steps and then put it all together. So this first one is going to be my inequality number 1. And the second one is going to be my inequality number 2. And the reason I color code them is so that I don't get confused when I go to write my inequalities. So the first thing I'm going to look for is I need my slope, I need my y-intercept, and then I need to know what y is. Is it greater than, less than, or greater than equal to, or less than equal to? So in looking at my first inequality, the thing that's always easier for me to find is the y-intercept. So I can see that this line goes through the 2 on the y-axis, so my y-intercept is 2. The next thing that I want to do is I want to find the slope. So I find another point of intersection on my graph, which I find over here on the x-intercept. And I see that I have to rise 2 here and run 1. So that means, but I'm running in the negative direction. So that means that my slope is -2. All right, any questions so far? Okay, now I have to look at my shading. And my shading is in this direction. So I see that it is below the line or above the line. So I know that y is going to be greater. I also see that my line is solid. So that means it's going to be also equal to. So then I just put all those pieces of information together, starting with y is greater than or equal to, and then my slope comes next in slope-intercept form, so -2x, and then my y-intercept comes last, +2, okay? All right. Sure, so hold on just a second. And let me grab. All right. Okay, go ahead, Christian.
Okay, so one thing I do see first is that the y-intercept is -2, so.
Okay, that's correct.
And one thing that I did point out is that, so the rise over run is going to be rise 3, run 1.
Yeah, because the next point of intersection is up here at 1, 2. So we go rise 3 and run 1. Good.
And the y is going to start out, I might need a little help on that one.
Okay, so look at your shading. Where is look at the overlap shading section. Yeah, it's below. This is where the overlap shading is. So since and that's how you want to gauge it, is you want to look at where the overlapping is and then look at what direction it is from the line. So in this case, because it's below, Christian, what will our inequality be? Will it be less than or greater than?
It's going to be greater than?
Below, the below you go low, so less than. And is it going to be equal to? No, it's not, because it's a dashed line. So let's put all of that together. There you go. So what I want you to do on the next one is I want this one to be inequality 1. And on your homework, it won't matter, but just for notes purposes, and this one to be number 2. And I want you to go ahead and you can use my method or your own method, whatever works best for you. Okay, check your answer for example 6. It almost looks like this is the overlap section, but when I look up here, there's no shading up here. So that tells me that it shades below the line on both of them. The next 2 that we're going to do are a little bit simpler. I think they are, I don't know. Okay, any questions before we go on to number 7? Okay, so I will do 7 with you. We're going to name, this one is going to be our first inequality. This one is going to be our second inequality. Okay, so I am going to have M, B, and Y. And the first thing I'm going to look for is my y-intercept, and I see that it goes through the y-intercept at -4. Okay. And then my slope, I see that the next point of intersection is at 1, -2. So when I rise and run, I'm rising 2, running 1 in the positive direction. So my slope is 2. And now the shading. The overlap is above my line, so it is going to be greater. And since my line is dashed, it's not going to be equal to, so y is greater than. So putting that all together, y is greater than 2x minus 4.
And for number 2.
Okay. All right, so let's look at the next one. My y-intercept for my second inequality is at -1. And then the next point of intersection is at 2, 0. And that tells me that I am rising 1 and running 2 in the positive direction. So my slope is a positive 1/2. And the overlap is below that line. And so it's less than, and since it's solid, it's equal to. So y is less than or equal to 1/2 x minus 1. Okay. All right, on the next one, example 8, I want you to make this inequality number 1 and this one inequality number 2. Okay, like that. Okay. So go ahead and work on that one. Okay, go ahead and check your inequalities. Okay. There is more. There's word problems. It's okay. Okay, let's go to the word problems. All right, so example 9, you're planning to get an after-school job and you need to balance your time between your jobs and doing your homework. And this is something that you guys actually have to do, and it may not necessarily be a working job. Maybe you have athletics, or maybe you have chores that you have to do at home. I know some people who live on farms and ranches that they have to go out and feed or exercise their animals or do whatever. So there could be obligations that you have where you have to balance your time. And so that's what this whole word problem is about. Okay, so we're going to pull out the key information. You can work no more than 12 hours a week. Okay, so I would think that that would be within a weekday. I mean, weekdays, but maybe it's including weekends. You need to earn at least $36 per week. Okay. Your lawn mowing job pays you $6 per hour, and we're going to represent lawn mowing with M. And your dog walking job pays you $4 per hour. We're going to represent that with the letter D. And you are going to write a system of inequalities to model the situation and graph the results. Bless you. Okay, you need 2 inequalities. And the first inequality is going to represent your hours. Another inequality, the second one, is going to represent your pay, your earnings. So I want you to think about what your possible inequalities could be. And then I want you to write them down and compare them to what they actually are, and see if we've gotten anywhere with writing inequalities based on word problems. Okay, so for the first inequality, we so far have 6m plus 4d. So you have to earn at least 36. So yes, at least means you can earn more than, but you can earn at least or equal to 36. Okay. Now the next one's going to represent the total number of hours. We're still going to use M and D. I'll give you a hint. M and D don't have coefficients. Okay, Jaden, then tell us what it is.
M plus D is less than or equal to 12.
Why less than or equal to 12?
Because it cannot work more than 12 hours.
Right. These are the number that you're going to be working over here has to be less than or equal to 12. That's right. Okay. So now that we have our inequalities, we are going to graph this scenario to figure out how many lawns and how many how many lawns he can mow and how many dog walking jobs he can have. And so what the first thing that you need to do is put these into slope intercept form. So if I were to tell you that we're going to put lawn mowing, lawn mowing on the x-axis and dog walking on the y-axis, what variable will we isolate? So normally we isolate the y, right? Yes, because dog walking is on the y-axis, that represents our y-intercept, we're going to isolate the d. So let's take this first equation, 6m plus 4d is greater than or equal to 36, and we're going to isolate the d.
So we have to.
What would we have to do? What?
40.
No.
6m.
We're going to subtract 6m because we want to get d by itself over on this side. All right. So when we do that, we're left with 4d is greater than or equal to negative 6m plus 36. We still don't have d isolated. So now we are going to
Divide
by
4.
So d is greater than or equal to negative 3/2 m, because we want to simplify, plus 9. 36 divided by 4 is 9. Okay, so we have this one into slope intercept. Let's turn the next one, the other one, into slope intercept. M plus d is less than or equal to 12. We want to isolate the d. So we're going to do what to both sides? Subtract m. So d is less than or equal to negative m plus 12. And we're done. Well, we're done turning them into slope intercept. Now we have to figure out what increments we want our x and y axis to go by and what we're going to title our graph. Sure, jobs.
Time wasted.
Okay, I noticed that your y-intercepts are 9 and 12. So we could go up by ones, really, because it will go all the way, it will go past 12. We're going to go up by ones, and we're going to go on the y-axis by ones. Okay, so this is 0.
17, 18, 55, 43, 520. You say 6.
Okay. Now, once you have your increments, we're going to start graphing. So this first inequality, I will plot a point at 9 on my y-intercept. And then I'm going to go down 3 over 2. Why don't I have any other quadrants for this graph?
Negative hours.
That's right. You can't have negative time or negative money. Well, you can be in the red, but let's hope that we don't do that. Now, I am going to shade when you're talking about like money and debt. So I'm going to shade above on this one.
That should the whole thing. Except for like 14 squares.
Pay them bills.
Nah.
I'm gonna take it over to GTA just for running things.
What?
I have millions of dollars in GTA. It's not that hard to rob a bank.
No, I have trillions of dollars.
You've never played GTA.
You'd have spent hundreds of.
Oh, it's a game.
This was really over here like they're gonna rob a bank.
Okay, let's go ahead. Once you're done shading that, go ahead and graph your second inequality. We're going to start at 12.
Actually, I'll grab one of those.
Notice these are both solid lines, meaning a solution can be on that line. And now we're going to shade below this line. That's right. We're going to shade below. Nick.
But then I can get me blizzards. But then I can make myself like 20 blizzards to go.
You can't just take all the stuff that you need from the customer. And it would just be over there eating everyone before you pass it.
Okay.
You just lick it and give it to them.
Yeah, I'm hacking.
Christian, you're not hacking.
Okay, let's get back on track. This is what your graph should look like. And as soon as everyone's done, we're going to interpret this graph. Okay, so this is what your graph should look like. And we're going to select an ordered pair that is a solution to both equations just to see how it works. So I'm going to choose 8, 2 right here. So what does the 8 represent in our graph?
8 hours mowing the lawn.
So the lawn. So if I chose 8 for lawns and then for dogs, 2,
8 lawns and 2 dogs.
I can mow, well, I can mow 8 hours of lawns and 2 hours of walking dogs. And how many total hours is that? 10. Did I fall within the range that I wanted to? Is it less than or equal to 12? Yes. So that's the solution. Now, what about the money though? I make $6 an hour for mowing lawns. So 8 hours times 6 is 48. And then I make $4 per hour. Yes, then I'm good. I really don't need to go on. $4 per hour walking dogs. So that's a total of 8 hours. So that gives me a total of 56 hours. No, $56. Whew, 48 hours of mowing lawns. That's a lot. So I make $48 and $8 for a total of 56. Did I make at least $36? Yes. And so that's how we can interpret these inequality graphs.
Yeah, one day.
Okay. Okay, let's go on to example 10. I'm going to read through the problem, but then referring back up to example 9, I want you to try to come up with your own equations. Okay, you want to bake at most 20 cupcakes to sell on Valentine's Day. See, so this lesson was supposed to be prior to Valentine's Day, by the way.
Oh, yeah.
You want to bake chocolate cupcakes and sell them for $2.50. So chocolate cupcakes, that's going to be represented by the letter C. And then you want to make vanilla cupcakes that will sell for $1.25. So we're going to make that variable V. Your goal is to make at least $30 in sales. So you are going to have an inequality that represents the number of cupcakes you sell and an inequality that represents the cost of cupcakes. I'm going to give you a couple of minutes to try to come up with your two inequalities. Please refer to example 9 for help. Okay, no talking at this time. Okay, here we go. Andy, give us one of the inequalities.
Inequality number 1, 2.50 or 2.5c plus 1.25b is greater than or equal to 13.
Exactly what I.
Amen.
Good job. Okay, Emma.
C
plus B is less than or equal to 28.
Good. Okay. Our next step is to put them into slope-intercept form, but we have to figure out which one we are isolating. So we are going to put vanilla on the x-axis and chocolate on the y-axis. So which variable will you be isolating? Vishawn, which variable are we going to isolate?
Here's a hint, not vanilla. B.
Look at the AJ.
Wait, no, I thought you were talking about like B.
No, listen. Which is on the y-axis? So we're going to isolate the C. We're going to isolate the C. So I want everybody to rearrange both equations to isolate the C. Okay. So these are the inequalities you should have gotten.
I don't think we can go up by one.
We can't because the farthest it will go up by our would be 15. Twos are going to be a little bit hard. I'm going to have to show you how to graph when you go up by twos, but we could do it.
Okay.
So what's the name for our graph?
Valentine's
Cupcake sales.
Valentine's Day reminds me that no one loves me.
Oh.
Yeah,
same.
Same. Christian does.
Okay.
I love
I didn't know that.
Yeah.
We're going to go up on the y-axis by 2 and on the x-axis by 2 ones. 2. Okay. No.
We do not need any more comments from the Connect
Okay. I would like to graph, but I have to show you because we're going up by 2s on the y-axis. It's a little bit tricky. So because we had to go up to at least 20 and the graph would only go up to 15 if we went by 1s. So let's graph this first inequality. We have to start at 12. So I'm going to plot a point at 12 on the y-intercept. And now we go down 1 over 2. Now the problem with going down 1 is that my increments are 2s. So you go down a half and then over 2.
Oh, that's easy.
Down a half and then over 2. Down a half and then. Now for those of you who can understand this, if I took negative 1/2 and I wanted to go down a full square, that means I'm going down 2. I could multiply this whole thing by 2 over 2 and get negative 2 over 4. So now I could go down a full square, but then I'd have to go over 2 squares. Now, if that confuses you, I don't want you to do that. Okay, and now I'm going to have a solid line.
It's not. You are?
And am I going to shade above or below? Above, there you go.
You did such a good job.
Okay, shade.
Oh, I'm running out of pencil.
Wow, it looks like it's just like magically showing up.
Yeah.
Because of the lag.
Oh yeah,
It's like your hand's moving super slow. Like it's just there.
I gotta watch it then. Hold on. Oh, there is a lag.
Yeah.
This one would just like let me watch my.
And it looks like it's moving once, but actually you're moving it like 30 times.
Okay.
And so it's just like it's like a
It's like a
magic
magic
pen.
It's like the magic marker.
Okay.
Magic pen.
Now, when we go when we go to graph the next equation or inequality, we start at 20. And now we're going down 1 over 1, but remember, since our increments are 2, we have to go by halves. So you go down a half and over 1, down a half and over 1. Now, if you start seeing a pattern, you'll see that we're actually going down 1 full square and over 2. So you can like graph that pattern if you see it. If you don't see it, then just keep doing this.
Just get this. Oh, wow.
Who are you talking to?
Who?
Dollar Tree has some talking about.
Hey, him in the background. In the back. Oh, yeah.
Okay, on this one, we're going to shade below.
Nothing you can do about it. I can't bump myself. Yeah.
Oh yeah, below.
Until 8 in the
I thought I
morning.
shaded.
Oh, look, I see the screams in there, right? Like, well, that's not him.
Boys, are you shading and all that good stuff
Yeah.
while you're talking?
We're good on most parts.
Sure.
Miss Weatherman, letting them talk is.
I know.
Letting you
Letting-
talk is a bad idea.
Oh.
Andy.
Oh my goodness.
Well, y'all
Let's
heard
not
it.
roast him too hard.
That was Andy. That was not very nice.
He's like, but it's I agree. It was not.
All right, this is what your graph should look like. So we are going to find a point of intersection that will make both inequalities true, but we want to interpret what that means. So if I were to choose, will somebody give me an ordered pair that's true for both inequalities?
6, 12.
6, 12. Is that right? Oh yeah, 6, 12, it is. Okay, so 6 represents vanilla. So vanilla is 6. And then chocolate is 12. So what does this mean as far as the number of cupcakes?
18.
They made a total of 18 cupcakes. So is that less than or equal to 20? Yes. So that's a solution. Now, if they charge $2.50 for chocolate, so that's times 2.5, and then they charged $1.25 for vanilla, we have to make sure that they're making at least $30 in sales. So I'm going to calculate this up, unless somebody can do it in their head really quick.
6 times 1.
So
Like 10, 1.5.
No, it's 7. It's 7.2. Like it's not.
good job.
Normally you're right.
No.
Oh, it's
So altogether, they made $37.50. Is that at least $30?
No, that's.
At least, it is at least.
no, it is definitely less.
So this is a solution to this inequality. Okay. All right, let's go to the back, please.
Let's grab multiple. Yay.
Okay. Okay, on the back page, we are graphing more than 2 inequalities just to see what it would narrow it down to. If the more inequalities you have, the narrower your results. So we're going to start with this one right here. And let's go ahead and graph that inequality. We're going to graph a point or plot a point at -5 on your y-axis. And then your slope is 4 over 3. So you're going to rise 4, run 3.
4, run 3.
And this is going to be a solid line. Boys. And we are going to shade above. Okay, because y is greater than. Remember, use your arm to help you if, oh, no. Oh, thank you, Sophia. Okay.
Oh, that's another large amount of shading.
Yes, it is.
I'm running in.
Okay, now I'm going to shade this next one. Now this next, or I'm going to graph this next one. It's a little bit different. What do you notice this inequality does not have?
An X.
Which means it doesn't have a slope. So we're going to plot a point at on the y-axis. There you go. Good. Okay, and then you're going to have a solid line going through y. Okay, and then you're going to shade. Lots of shading here. Okay, so this is what it should look like after you've graphed this, the second one. Now I'm going to graph the third one, and it is y is less than 2x. What does this one not have? Whoa, raise your hand if you can tell me what this does not have. Emma.
It doesn't have a slope. No, y-intercept.
So where will we plot our y-intercept at?
Origin.
0, the origin. Okay, and then you're going to rise to run 1. And on this one, are we going to have a dotted or a solid line?
We are gonna have a
Dotted.
Okay, this is what your graph should look like for example 12. And it's this middle section right here. So it includes quadrants 1, 3, and 4, but not 2. So I want you guys to try to do example 13. It says example 12 down here, but it should say example 13. Do this one on your own and then we'll check it. Okay. Okay, this is the answer to example 13 for those of you who were able to finish it. And the solution for this one is in part of quadrant 1 and quadrant 2.